Alright, with this presentation, I'm just going to kind of run through basics of what needs to happen to convert this car to EFI, and I will probably build on the presentation in future videos um, as I find out more information and some of the details. We'll actually add those to the presentation here so we can keep track of basically the whole project and the little details that was decided. So I have an overview of the system characteristics that I'm trying to accomplish here. I'll be using a micro squirt EFI controller as part of the mega squirt family, mostly because it's small, it's kind of waterproof or weather resistant, it's very affordable, and it has plenty of features for what I'm trying to do with this car. That will limit it to batch fire fuel injection, as the micro squirt only has two injector driver channels, A and B. That is, one set of injectors will fire, and then the second set of injectors will fire. So they will not be timed to the intake port opening. There's a lot of cars that used batch fire fuel injection kind of in the early 90s, and it wasn't until just recently that injectors were able to flow enough fuel and processors were fast enough to actually have full sequential, even at higher RPM. So we'll be sticking with the batch fire fuel injection and wasted spark ignition. And that is because the microsquirt only has two ignition channels. However, you can configure four. And because we're dealing with a V8 engine, you can wire these with complementary cylinders, such that two spark plugs will fire. One will be on the compression stroke, or you know, right about to combust, and the other spark plug will just be on a cylinder that has just burnt down and is on the exhaust stroke, so nothing will happen. And this works fine. I'm not trying to do any kind of individual knock control or anything like that, so this is used a lot on the Ford EDIS systems and the GM systems of the even early mid 2000s, I believe. And it's still used today on some applications. I'll be going for a return style fuel system. That's currently what the car has in it, so it's probably the easiest to just stick with that system. That is, the fuel comes from the pump, feed the fuel rails, and then a fuel pressure regulator will return the fuel back to the tank. This is kind of a basic wiring diagram for the micro squirt controller. It looks a little overwhelming, but it's really not that bad. You got here they're showing one injector channel with the blue and the other channel with the green in a four-cylinder arrangement. You can basically double that up for a V8. There will be some relays that power up everything, send power to the fuel pump and injectors and ignition coil. We'll have the oxygen sensor, throttle position sensor, intake air temperature, coolant temperature, manifold air pressure, somewhere here. I probably won't bother with the fast idle valve, though that could be something we look at in the future. And there's some extra inputs that are configurable. There's the map sensor. Let's look at the required inputs. Engine speed and position is absolutely required. That's how the ECU will time the events, such as the injection and the ignition timing. Manifold absolute pressure and manifold air temperature is used by the computer to compute the manifold air density. This system will be set up to use a speed density configuration. That is, if it knows there's a certain density of air in the intake and the engine's spinning at a certain speed, and it knows the displacement of the engine and the volumetric efficiency, which is what you tune into the computer, then it's able to compute the mass airflow into the engine. Then using the requested air-fuel ratio table, it will calculate how much fuel it needs to add. Throttle position is used for transients and accel enrichment so that when you open the throttle quickly, the computer can add extra fuel to compensate for the inrush of air. Coolant temperature used for warm-up enrichment and fuel adhere to walls and such things like that. Also, if the cylinders are hot, usually you get less air in there, so that can affect the air-fuel ratio. And then it'll also need AFR feedback or air-fuel ratio feedback, and that'll be used to verify our fuel maps are correct, and we can also use it to close the loop so that it can account for variations in humidity and just different operating conditions. Actuators, going to be pretty basic with this setup. I was just going to have fuel injectors, the ignition coils, and the fuel pump. It will turn the pump on when you key on and while the engine's running. Some optional actuators we could have, maybe a fast idle valve as we saw in the wiring diagram, or cooling fans, though the car has mechanical fans and I plan to just leave it like that for now. So to obtain the engine position, there's a few options. One of the options is just use the factory crank sensor. The car does have a crank sensor since it's able to control the ignition timing. The issue with the factory crank sensor is it's a very low resolution. I believe it's only 4 pulses, and it uses a combination of that and I believe a pickup, excuse me, a pickup in the distributor to figure out the ignition timing. Then we'll have to also tie into the cam sensor, or if it's in the distributor, I'm not sure exactly on this car. And actually, kind of a downside is the factor sensor availability. Pretty much any electrical component for this car is becoming increasingly difficult to find and very expensive. Option that's usually popular with any fuel injection conversion is adding a tooth trigger wheel onto the crankshaft. Fabrication be required because we'll have to add the trigger wheel to the crankshaft, usually on the front crankshaft pulley or harmonic balancer. This provides very accurate position and speed reference to the computer. If we only use the trigger wheel, we'll have no phase information, so we actually will not know if cylinder number 1 is on compression or exhaust. Though because we're doing the wasted spark, it really doesn't matter. And we could add a cam sensor or put a tooth trigger wheel directly on the camshaft or distributor. This would provide phase information. Slop in the drive system due to gear backlash or chain stretch. I'm not sure how tight the distributor shaft is to the engine crankshaft assembly, but that is an option. Manifold air inputs. You can use a separate temperature and pressure sensor. This is more traditional. It's usually cheaper from an installation standpoint as well as a maintenance issue, because if the one of the sensors go bad, you can just replace it instead of both sensors. does require separate wires to each sensor, and now you're trying to integrate two sensors to the engine. Second option is this combined sensor. The Bosch T-map sensor is a manifold absolute pressure sensor combined with an open element temperature sensor. It has a 4-pin connector, so it can use a shared harness. So then you only have one connector and a set of wires coming into it. I'd say it's a much cleaner install. Could be a little harder to integrate. The car was never set up for one of these style manifold sensors, so it usually requires adding some kind of boss to the plenum for this to attach to and poke through plenum to have the element inside, where the separate pressure sensors usually run just a vacuum hose to it, and then the temperature sensor can screw into the intake track or somewhere else. It's a little bit more expensive, especially if one of the sensing elements were to fail, you're going to have to replace the whole thing. But I think the cost should be very similar. Throttle position input. I know the factory throttle body does not have a standard throttle position sensor. I think it may have just a switch. Once you get to a certain percentage, it just is an on-off switch. An option is to mount the throttle position sensor on the side of the factory throttle body. I'm not really certain of the feasibility of this right now. Second option is just convert the intake manifold to use a popular throttle body, maybe something off of a LS1 engine, or some Ford products have some nice kind of universal looking throttle bodies. There's some things to overcome with this option, such as mounting the throttle body or adapting to it. Same with the linkage. Most throttle bodies use a cable, and this car actually uses a mechanical um, linkage or a solid rigid rod that connects to the throttle body. Advantages, you can also use a larger than factory throttle body. If that's a limiting issue on this engine, I'm not sure. For coolant temperature, um, most likely I would just use a standard GM negative uh, thermal coefficient thermistor. And again, the advantage to this is it's easy to find replacements, and the resistance versus temperature data is well known and available online. We'll have to find a location to install it, as the dash is most likely using the factory sensor, and I don't want to remove it. Thread options could be an issue. I'm not sure if there's already some spare threaded ports somewhere on the block or cylinder head, so we'll have to look into that. The alternative is to just use the factory sensor, which, as I mentioned, it might be used by the gauge cluster, so I'm not sure if that will interfere with the ECU, or the ECU will interfere with the gauge cluster. I'll need to establish the temperature versus resistance relationship experimentally. And once again, it's hard to find a replacement. Now, if it fails, I would just lose my indication on my gauge cluster. And in the case of still using the GM sensor for the ECU, the car's still going to have that data in the computer and be able to function properly. And it's just getting hard to find any electrical component for this car, which is another one of the big reasons why it's advantageous to convert to fuel injection. For the air-fuel ratio feedback, I've used these quite a few in the past and for work. The Innovate LC2 wideband controller, which is actually this guy, and the sensor, which I believe is just a Bosch wideband sensor, but you need a controller to actually send out a good signal that an ECU or a gauge can use to establish what the air fuel ratio is. And this will just thread into the factory location. I believe the factory oxygen sensor is just a narrow band sensor, so we'll no longer need that. For injectors, I plan to use the Bosch EV14 injection valves. These are the most modern, I think, injector out there as far as a port fuel injector. They come in various sizes. You can get the compacts, the standards, the longs, and then all options are also available with the extended nozzle tip. And this may be useful in this installation because I know the mechanical injectors are very long. They go through the intake manifold with a air shroud piece around them that's hard to describe. But it's a very long mechanical injector. The ignition coils, there's quite a few options one could choose doing this conversion. Um, Using these coil packs, I believe these are off of Volkswagens. They're 4 towers, they're double-ended coils, so there's 2 ignition coils here. It has its own, actually all these options we'll be discussing have their own driver built into it, so you can just send it a logic level signal, which is all the microsquirt supports. Um, with the 4 towers, you get less wiring. You only need to mount 2 coil packs, and you just run wires to each tower. One negative thing is if a coil goes bad, you're going to end up losing 2 cylinders, since only one ignition coil is here and fires both of these towers. There's a coil on plug option where you use like a pencil coil and mount it directly to the spark plug. The cylinder head is not really conducive to this. This is looks like an LS cylinder head, but my spark plugs are in the same location. And so you imagine if you mount an ignition coil out here, it's just going to be kind of in the middle of nowhere. There's the coil near plug, or LS style. These are very high power ignition coils, even the factory GM ones. Readily available pretty much anywhere. You can go to any parts store and just pick one up if one were to go bad. It is more wiring, as you have to mount or run wires to each ignition coil, and you'll have to gang them up to create the wasted spark setup, as the microsquirt only has 4 ignition drivers and we would have 8 coils. Having 8 coils, you have to mount them somewhere. On the valve cover is a nice option, but my valve covers don't have any mounting provisions for that, so that's extra fabrication. I believe the coil packs will probably be the route I choose for this project. The fuel system of the car is already set up for high pressure injection. It has a return going back to the tank, and I believe it has a fuel pressure regulator somewhere either on the firewall or on the engine, so I'm not sure if I'm going to be able to reuse it or I'll have to come up with my own fuel pressure regulator. I believe the car already has a fuel pump relay, so I will just have to tie the trigger wire to the microsquirt. Looks like this one's just set to come on with a key, but I'll let the ECU basically be this key switch for the relay to power up the fuel pump. Next video we'll be looking at research into previous works. So we'll be just doing some Google searches and see what other people have done, and also a little bit about how factory fuel injection system works in the car.